Thanks, Owen. Yes, welcome everybody. Glad you could join us today for this first part of our webinar series, which is, as Owen said, replacing the masterclass that we had lined up for Valencia. Unfortunately, we won't be having lots of demos in the masterclass series, and there would be a bit less social interaction, and there won't be any coffee breaks today, but I'm sure you can fix yourselves up later on. Can you go forward, Owen? Rufael. Next slide. Next slide. Yeah. Okay, so just a little bit of background about DVB-I and where we are and how we've gotten to the stage today. For a long time, we've had, DVB's had a lot of history in broadcasting, linear services. Probably most of them, well, just know about our other specifications for cable, terrestrial, and satellite broadcasting, and they really laid a lot of the groundwork for live linear television in the digital age. We still understand those technologies are relevant today, and we bring lots of aspects of those forward into the current work we're doing with DVB-I. We also have HUB-TV, a companion set of specifications that looks at, it brings interactivity to the web space, the TV space, but it also brought a lot of the concepts that we're starting to see now that form the basis of DVB-I. XML and HTML were really not, I'd say pioneered, but for the television space are really driven by the HUB-TV activities. In addition, then, DVB has worked a lot with IPTV in the past, delivering linear television service over IP networks. They were managed networks that were operated by service providers and have been quite a good service up to date. And so that we've had a lot of experience in that case of understanding the differences between a broadcast signal and equivalent of a broadcast signal, if you like, on an IP network. To date, we've got 4 different specifications, blue books. Some are already published with ETSI and some are not. A177 talks a lot about service discovery, how we go and find these services if we're just connecting to the internet. A177 aims to be the search engine, if you like, for internet-based channels, as well as supporting broadcast delivered channels as well. And at some stage, not in this webinar, but in the one, I think the next one, Nicholas will be talking about that. We then have the A168 specification, which is all about DVB DASH and how we create content for low latency. HTTP streaming has been around for quite a long time and it's been very successful with VOD services. Had some transitional phases towards live services, and now that we've added low latency in there, we really are to have technology on par with timings to broadcast. Then we have 2 other specifications, multicast ABR and targeted advertising. These are adding in services and functionalities to support the service itself with its targeted advertising and support the efficient delivery of DVB DASH using multicast. If you can go on, Rufael. So I'm not an artist, but I certainly tried to draw this out and pinpoint a few of the key features of DVB-I. On the right-hand side, we have the player, the television set. It could be a mobile phone, could be a tablet, could be any kind of device. We've tried to keep that well abstracted in our work with this technology. It basically then, that device with that application on it will go and look for service lists. It'll make some discovery processes, we'll obtain some service lists, and ultimately it'll do what we want from a media device, and that is attach to a service and start delivering it. In addition to that, we have program information. Where would we be without the now next banners that we're used to and the EPG grids? So we have support for all of that. But and then the delivery of the service, in this case over broadband, through some sort of low latency managed CDN. Can you go on to the next slide, Rufael? And today, that's really what we're talking about. These highlighted areas are the delivery of the service. Once we've had it created, and Rufael's going to talk a lot about how you go about constructing a service, the media aspects of a service, what it means to be delivering those to a client and playing them out. Next slide, please. So then I'll hand over to Rufael. I don't know if Dirk is joining us today, I don't believe so, but Rufael will then take us through the rest of the webinar today. Thanks.
Yeah, thank you, Paul, for the introduction. So this is a presentation about the encoding and packaging aspects of broadband support for DVB-I, which, as Paul mentioned, is based on the DVB DASH specification. So I will be presenting, and this work is a joint work with Dirk, who is one of the founders actually of unified streaming. So let's continue. Let's jump right in. Welcome everyone. So basically, I'm going to give a presentation about this important topic of packaging and encoding for broadband. So as Paul already mentioned, so DVB-I services are live services, basically DVB-I services use DVB DASH as a transmission format for broadband delivery. And in DVB-I, there is a service lists basically are published, and those lists, they basically reference manifests, MPDs, that are stored by the origin servers. So one important topic is like how you create these live feeds in the origin service. And to help with that, in this presentation, I'm going to give a reference architecture with different components that have different functions. So it's like a distributed workflow. I will show you in the next slide. And this architecture is developed also in the DASH industry forum, which do a lot of the specification work and the promotional work around DASH, which is also often used as a basis for the DVB standards for DASH as well. So just to first summarize some of the goals of this workflow is like basically if you want to start encoding and packaging for DVB DASH or for DVB-I, there are some important goals that you want to achieve. So firstmost, you would like to have interoperability with the DVB DASH devices. So basically to support DVB DASH and all it has. So DVB DASH has some additional requirements compared to and constraints compared to MPEG DASH, so the original MPEG specification. Further, for many, it will also be important to be interoperable with other devices, such as HLS devices or other devices that you may want to target. And then another important goal, if you're doing streaming in general, is that if you are creating, for example, DVB-I live service content, you still want your content to be interoperable. And with that, I mean that you would like to be able to reuse this content for other purposes. So basically to repurpose it. So you want to stream your content as live, but then later on you want to also provide the catch-up service, maybe a VOD service based on the same asset, or to broadcast it again as a live service. So that's important when you are designing a workflow for packaging and encoding as well. And then an important aspect that actually I will touch on in this presentation is how you can achieve interoperability between different components in the architecture. So a challenge that many broadcasters and telcos face that are deploying live streaming is to interop different components in the workflow. So I will shed some light on that. And then also some important goal is always the support for DRM. So DRM is not part of the DVB DASH specification itself, but it supports the use of commercial DRMs available, such as Whitevine or Marlin is another example, and so on. So, and then another important aspect that is becoming also more relevant, it seems, this year, is content insertion and replacement. So basically, you want to monetize services in different ways. So you want to be also sometimes people pay for their subscription, and sometimes there are extra ads inserted or more personalized ads inserted. So these are some of the goals. So let me just jump right into the example architecture for the encoding and packaging front end. So basically the architecture that we discussed in the DASH industry forum when we were developing a for low latency was that the entry point to the ABR streaming workflow is the ABR encoder. So the ABR encoder is sort of responsible for encoding the different tracks with multiple bit rates and with fragment boundaries. So one key difference compared to broadcast over terrestrial or satellite is that in online streaming we encode in multiple bit rates that are used in the streaming representation itself, and that there has to be a clear segmentation of the media as to allow clients to request segments and switch to different qualities as well. And then another important aspect of the encoder is to implement the right media coding profile. So basically to have the AVC, HEVC content conforming to the right profiles as defined in DVB. So there's content encoding. Then the second step would be sort of the content preparation. So for packaging, with content preparation, I mean packaging. You need to further have your streaming manifest, your content encryption, and then you need to deal with your origin servers and your CDNs for sort of handling the load of many clients doing requests for content. So in this reference architecture, the packager and origin are two other important components. And then for delivery, there is the CDN part. And then in the DVB-I architecture, there is some link to the DVB-I service that references some of these MPDs in playlist and so on. So basically, clients can discover these services and then get the manifest and stream the presentations. So one part is the encoder architecture, and the second part we will talk a bit about the packager, origin, servers, and connecting with DRM. And then later we also have MPD Proxy. So I will come to that later in the presentation. So basically, the encoder pushes the adaptive bitrate tracks, for example, using the CMAF format. Then the packager is responsible for encryption and manifest generation. And then the content is distributed through the origin and the CDN. But in some cases, you want to add some specific information to the MPD, or you want to do some specific changes to the MPD that do not change the segments. So sometimes you can do this at the edge, and for that there is a component called the MPD Proxy, which in some cases can be responsible, for example, for insertion of content. All right, so is there any initial question about the architecture? All right, then I'll jump.
No,
Yes.
we do have one question here. It's not specifically about the architecture, but I think it's a good basic question that may be on other people's minds as well. The question is whether you can elaborate whether there is a difference between DVB DASH and MPEG DASH. Do they both refer to the same packaging formats?
Yes. So the answer to this question, it's a fair question. So basically, how standardization works is that in MPEG, that is basically the standards organization that standardized DASH. It's an international standard where many companies send their delegates. So basically, MPEG DASH is a broader standard than DVB DASH. So that MPEG DASH is the more general purpose standard. And then DVB needs to, for their requirements of their clients and to make it work with their devices, they basically add constraints. So basically what I can say about this is that DVB DASH is a constrained version of MPEG DASH. So not all the features of MPEG DASH are supported in DVB DASH. And some of the features of MPEG DASH are mandatory in DVB DASH.
Good, and indeed, of course, this is really about adapting MPEG DASH for the broadcaster use case or for the media delivery use case from the perspective of DVB's members. There is one more question there which you might want to deal with now, or you might want to push off until later. Can you move directly from the packager to the CDN, or what does the origin achieve in case the packaging is done on premise?
Yes, so this is a reference architecture. So it's our mainly functional blocks. So many CDNs have an origin server as their entry point. Some people run an origin server centralized. In our case, our preferred approach is to combine the packager and the origin server because it gives you some additional flexibility. But all these things are possible. And the nice thing of the DASH-IF architecture is that there are just some interfaces defined to interoperate between entities that could implement these functional blocks. But doing it this way is not mandatory. If you want to, so indeed you can, in some cases, the packager can push directly to the CDN, but at the CDN there will also be an origin server to retrieve the content. So in the end, it's more or less the same architecture.
Okay, good, thanks. Clear answer. I think you can move on, and for our attendees, you can feel free to post your questions in the Q&A format, and we will have plenty of time for dealing with them at the end of the presentation. Carry on, Rufael.
So one important part for DVB Dash is that so one important work for DVB is to basically define the coding profiles. And this is important to make sure that basically this is again sort of the same kind of issue that MPEG or ITU define as standards, such as H.265 or H.264. But then DVB still needs to implement to decide basically on how they want to use that standard. So they need to make some constraints on certain options and so on to make sure that their devices can work with the streams, because again, H.265, H.264, these are international standards sort of developed for the whole world, while for DVB is a more application-oriented standard. So in this slide, what you can see is the reference of the coding profiles for DVB has a section on coding profiles for DVB Dash. So this is an important sort of interop point. So if you want to set up a live encoder and you want to sort of make sure that you can encode good content for DVB Dash, make sure you check those requirements. Because that is what will guarantee you a high quality sort of playback and will guarantee you like interop on the codec level. And then a second specification that I would also like to recommend is the CMAF specification, which also developed some media profiles. These media profiles are a little bit more for the less, again, CMAF is also an international standard, so it targets a bigger space than just the DVB space. But CMAF is really geared towards delivery in online web-based, so basically adaptive streaming format. So, for example, for DVB Dash, if you check the DVB Dash specification, it's still allowed, for example, to do interlaced, while in the CMAF media profiles, this is not allowed, and you have to stick with progressive. So by checking both specifications as a broadcaster or content provider, you can make sort of decisions to have your content in the most interoperable format, which for streaming would be progressive format, which is also supported by DVB Dash and DVB. So that seems fine. So then another sort of aspect of DVB Dash is that the 2014 version basically includes already AVC, HEVC, stereo, multi-channel, and so on. But the DVB Dash 2017 profile also has support for HDR, high frame rate, and next generation audio, which is MPEG audio, which is basically a 3D form of audio. So these are some important advances in DVB for enabling sort of interoperable encoding at the encoding level. And in the picture, so you see some of the technologies that are included with the DVB Dash encoding. So there is support for video coding with AVC, H.265, AAC, but also Dolby DTS audio is included with the specification. All right, we go to the next slide. All right, so that's more about the profiles of the encoding. So when you are deploying sort of a practical deployment in either using your own servers or in the cloud, it's important to define sort of your input and output formats So in some cases, like in the beginning, streaming was sort of an add-on to existing broadcast services. And in that case, even a DVB broadcast feed could be an input to this ABR encoder entity. But if you want to achieve better and higher quality, you may use more specialized contribution formats. In the slide, I given some examples. And then, as I mentioned before, for the output, we recommend to produce fragmented MP4 or CMAF as an ingest to your, basically to your streaming head end, front end. Mm-hmm. Any questions so far? All right, then I will continue.
There are a few questions, but let's hold them off and we'll deal with them at the end, Rufael. Thanks.
Yeah. So one of the oh, am I muted? Can you still hear me?
Yes, you're good. Go ahead.
Yeah, I got a message that I was muted. So basically, an important development that we've seen in the last 3 years, actually. Yeah, 3 years, is the development of a new specification for using fragmented MP4. It's called the Common Media Application Format. It's also an MPEG specification. The good part of it is that it's an application format. So it just uses, actually it uses existing technologies. So it's basically, it's just a prescription of how to use MP4 for streaming. So it's a specifically usage of MP4 for streaming. And the specification also includes, as I mentioned previously, some information about media profiles, such that media can be encoded in a way that's interoperable for streaming. And one important aspect of that is to support the bitrate switching. So in streaming, you have this property that clients can sort of switch the quality of the bitrate. And for that, you need to prepare your content with similar aspect ratios, similar color spaces to be used in order to avoid that you get some flickerings or some brightness changes when you sort of switch to a different quality. So that's another important part of the CMAF specification. Another important part is that it sort of standardized the way in which fragmented MP4 is used. So before this, there were standards like, for example, the smooth streaming specification that added some proprietary boxes to the MP4 format, which is allowed by the specification. The specification allows for this. But for broad interoperability, it's much better to have an international standard and standardized boxes to signal these fields. So this is sort of something that CMAF provides, and which also makes it not only an industry standard, but also, as I mentioned before, a suitable ingest format. So I'm just going to give a small overview of what an example CMAF track looks like. So in CMAF, it supports adaptive bitrate streaming, and each quality or each bitrate is its own track. So in this CMAF track, you have a CMAF called a CMAF header, which includes the file type and movie boxes, which is basically the first part of an MP4 file. Then the CMAF track can also have a SIDX box, which is a segment index box. For live, it's still a bit tricky because this you can only add at the end. So what segment index does is it gives you indexes to where all the segments are, or the fragments. So there's some additional terms introduced in CMAF. So there's fragment, segment, chunk. But in the end, the main idea is that these structures are a combination of a movie fragment box and an MDAT box that contains sort of a closed gob of content, sort of an independently accessible piece of content, and the timeline is continuously increasing. So your media decode times are increasing and there are no gaps between fragments. So basically each fragment following in the track are contiguous and they are not overlapping. So CMAF tracks is just a valid MP4 track with small pieces, small fragments that can be downloaded independently by clients. So in this proposal, or sort of in this presentation, we are saying that this is a good format also for encoders to push their content, as they can use HTTP post to post the header and the fragments to the receiving packager or origin server. And then there are also some new boxes introduced in the CMAF specification, or not really new, but they have been adopted. So there is the segment type box, which allows you to signal what kind of fragment you're dealing with. Producer reference time, which allows you to signal sort of creation timestamps, and an EMSG, which is a box that was added to add some additional information for either metadata or instructions for the players. So this is sort of the structure of a CMAF track, and then a CMAF presentation is composed of multiple tracks, and it maps very well with DASH and also with HLS. So it's a sort of an interoperable format. All right, I'm going to continue. So one thing that we did in the DASH IF was to basically take this new specification that came from MPEG, and it was all supported by Microsoft and Apple, to sort of further standardize it for the use of ingest. So basically to use it in combination with the post method. So this interface, you can use it to push content from your live encoder to your packager or origin. So I provided the link. It's been published by the DASH Industry Forum, actually this week, after a year and a half of work with a lot of companies. It has basically two profiles. So one is to just push CMAF content without a manifest, and there's a second profile where you also post the manifest. So this is when you have an encoder that produces a full DASH or HLS presentation to push that to an origin server or a packager. Or in some cases, you could use this second interface that also adds the manifest as an output format from your packager. So these are just some standardized interfaces that you can use in your workflows. I'll go to the next slide. So just some advantages of CMAF as ingest and storage is that you can basically use different manifest formats. So by using CMAF, you can also support in your workflows, for example, HLS. This is an advantage as not all players support DVB DASH. And then also for VOD presentations, you can use it. Also, there's another feature in CMAF, which is called CMAF chunking. So that basically you compose a fragment of multiple chunks. Basically, you chop it into smaller pieces that may not be a closed GOP. And by having this throughout your workflow, in some cases, you can achieve lower latency. Then another feature of CMAF is sometimes not well understood, is that CMAF is a standardized format that also allows you to signal the language, the bitrate, and the track roll in a standardized format. So this is beneficial. These are important features, especially in DVB DASH. It's mandatory to signal the roles of your track, the language of your track, and the bitrate as well. So that's important. And then another sort of important design aspect of CMAF is that you can do this late binding principle. By making the manifest later on, you can basically decide which tracks you want to combine based on your user base, or maybe even based on the region that you're serving. So that's another advantage. And then as I already mentioned, so we added a live uplink protocol to stream this content in the DASH IF ingest specification. And another very important thing of CMAF, which is not fully reality today, but it's closely getting there, is the support for common encryption. Actually, that is already supported, but the main idea, what is envisioned is that DASH content and HLS content can use the same encryption scheme, and thereby avoiding having multiple segments in the CDN. So that was actually one of the main sort of goals of CMAF, but it's still not fully completed as they still use different encryption schemes. They both use same, but they use a different sub encryption mode. All right, so that's basically what I wanted to talk about when talking about ingesting from the live encoder to the origin server or the packager. So another important step is like how do you encrypt your content? How do you get your key information? How do you interrupt with DRM providers? So for DVB dash, as I already mentioned, so there is not as part of the standard, there is no specific support for DRM, but you can use commercial DRM such as Widevine, which is developed by Google, or PlayReady, or for example Marlin. So one important aspect to get from your DRM sort of service provider is the key information, and maybe also some instructions of what DRM type to support, and so on. So to achieve this, so here we have our ingest. There is another specification which is developed by the Dash Industry Forum, which is called Content Protection Inter-Exchange, and that allows you to sort of exchange DRM keys, and that's especially important in more complex use cases where you have sort of HDR content or HD content, and you have different keys for different qualities, or perhaps you have key rotation where the key changes over time. So that's when the exchange of keys becomes more complex, and that's how, as Paul already mentioned about XML, so CPIC is an XML-based format, so it leverages that to have a standardized format for key exchange. So here's just an example of a very simple sort of CPIC file, so it's an XML file. So one thing that a DRM provider can do, it can just provide a CPIC file. So basically the most important elements are this content key list, where you have content keys with a key ID, and then the content key is included. And then you have your DRM systems list, where you can signal which DRMs you want to support. The specification has many more sort of things that you can configure. So you can configure your encryption modes and so on. So that is CPIC. So the simplest use case is just the DRM provider sort of providing a CPIC document, which includes the keys and the key IDs and so on. A bit more advanced use case is to build an API around this. So basically, a packager or another server can exchange a CPIC document where there is maybe a key list, but the keys are not yet included. So this could be seen as a request for keys. So you send the XML to your DRM server, and then you get a response that includes the keys filled in by the DRM provider. So an example API was developed by AWS. It's called Speaky. And just so to avoid any confusion, so there was some confusion around Speaky because they were using CPIC, but they made some changes to it. But I can report to you that actually they came back to the Dash Industry Forum and they both updated Speaky to be fully compliant with CPIX, and also some small minor updates to CPIX were done to be fully conformant with Speaky. But Speaky is also an API and not only an XML format. So if you want, you can use AWS Speaky, but you can also just use your own sort of exchange for CPIC documents. One important aspect, though, to realize is that the CPIC specification allows you to do in the document encryption of your keys, but in practice, this is not necessary. You can just use transport level security, so you can basically use TLS and HTTPS with digest authentication, for example, in your APIs to do a secure exchange of these keys. I just wanted to point that out. So I added the reference to the specification. I recommend everyone who's interested in this topic to have a look at it. All right, so now the next topic is DVB dash. So DVB dash is the main broadband delivery format chosen in DVB-I. As the previous question came up about the differences with MPEG dash. So there are some additional requirements. I cannot detail all of them now, but one important one is, for example, to signal the track roll and accessibility information. This is very important for broadcasters, and it's mandatory in DVB when you have multiple video tracks, and also for audio tracks it's mandatory. So what are track rolls? So for example, a track can be your main track, it could be a commentary track, it could be a dub, So for example, if you have a language translation, which is dub, then you have to mark your track as that in order not to confuse it, that it's not the main track. And then based on that, a player can decide which tracks to play. So for example, if you have in Italy, maybe you're using a dub track for the audio, then based on DVB dash, this player can just get the right track to play the Italian audio. Then there is some constraints on subtitling. So DVB dash uses fragmented subtitles with encapsulating TTML. So TTML is an XML-based subtitle format. This is also compliant with CMAF, but again, DVB dash chose a further constraint. So in CMAF, you can also use embedded caption, or you can use web VTT caption, but in this case, TTML is supported. And then there are some other constraints on the segment format, so non-multiplexed, which is also very aligned with CMAF actually. And then DVB dash also specifies some program metadata, so that you can basically see from the MPD or when you get your stream, like what you are watching basically. So I added a link to the DVB dash specification with the October update of last year. So anyone interested, I recommend to have a look at that. So now I'm gonna go a little bit deeper into this low latency aspect. So as Paul already mentioned, so streaming has been around for a while, mainly for VOD. It's also been used for live, but some people experienced latencies of up to 30, 40 seconds compared to the broadcast stream. So this triggered some work in recent years to reach at least parity with the broadcast streams. So DVB dash October 2019 has some updates to support low latency. And with you, I would like to just share some of the features of that. So when I talk to people in the industry, many people think that low latency is all about chunked CMAF. And I hope to summarize here what DVB dash chose to support low latency. So I made a small table to line it out. So one important thing is that basically what DVB dash and both MPEG did is they added some elements to the manifest to be able to instruct players to download and play back content a bit more quickly and a bit more efficiently in order to reduce the latency. So one of those elements is the playback rate element, which allows you to set a minimum and a maximum playback rate. And this allows clients to sort of catch up faster to the live edge. Then another feature is this chunked segments. So in this case, your segment can be downloaded progressively. If you use HTTP chunk transfer coding, you can basically request the segment, and while the segment is still sort of produced or not completely available, you get your bytes. So the content length is not yet known, but then while you're getting those bytes, you're sort of getting some small, they call it CMAF chunks, that you can already start encoding and playing, and therefore reducing the latency. One way to signal this in the manifest is by setting the segment profiles to CMFL, which is the brand. That basically would mean that that is a way to tell in your manifest that your content includes these kind of subsegments, these CMAF segments. Then there is a producer reference time. So this is an element that was added so that you sort of can add some additional information that the client can use to compute the latency, not only the latency relative to the origin server, but also relative to the time the content was encoded or when it was captured. And also it includes a UTC timing element to make sure that the client synchronizes to the same synchronization source as the producer of the content. Then there is a scope element. This is an element that is also used in the service description, which I come to after this. This is a DVB dash defines a specific scope, and this can be used by clients to identify whether an adaptation set is using low latency or not. So the service description is the element that contains both the playback rate, the scope element, and the latency element. And together you can basically sort of describe your service a bit better. So if you really want your service to be delivered at a lower latency, you have your latency element where you can signal the target, minimum, and maximum latency. And then, of course, you need to support that in your workflow physically by your content production and transmission. But this is the way to signal it in the manifest. So this is an example service description. So typically the service description is defined on the MPD level or on the period level. So you can have a service description. Here we see the scope. In this case, we use the DVB DASH scope. And then we set the target latency to 2 seconds. And then we also define a maximum and a minimum latency, and we define the playback rate. So basically we allow players to vary their playback rate in order to catch up with the live edge. So again, within DVB, there is still work going on to test how players can achieve this. But on manifest level, the signaling is already in place. So this is another example that I just wanted to include. This is maybe I can just briefly ask, is there any other question regarding to low latency support, as it's been a very hot topic, and I'm sure some of you may have a question around that.
So, Rufael, there is one question. There was a couple on low latency. If you want to take them now, we can do so quickly. Peter is asking, will the additional DVB DASH low latency features be part of the CMAF specification?
So DVB DASH is a standard that works on the MPD level. So what's defined in DVB DASH is mostly on the MPD level. And what DVB DASH currently is considering, how to support CMAF as a segment format. So CMAF only defines the segment and the track format. So basically the features that DVB DASH implements are independent of, sorry, they're not independent. They are using CMAF as the segment format, but as they are changes to the manifest format, they do not affect the CMAF specification at all. It's just that DVB DASH users can use CMAF, for example, for this chunked segments use case or these producer reference time in-band boxes. Those are also included in CMAF. So DVB DASH can leverage that, but I don't think there is sort of this other direction of DVB DASH needing to change CMAF. I think it's more the other way around.
Okay.
I don't know if that's clear enough.
Yeah, I think that's good. And one other quick one, and then we'll move on. Can we guarantee the stability of low latency DASH like we do with DASH? I mean, if we have less buffering, will there be more buffering errors and video freezes?
Yes. So this is a very valid question. So from a technology perspective, we are trying to push for this low latency and to have it in place. From a practical perspective, these are very valid concerns. And what we see is that for many broadcasters or people deploying these kind of services, that basically the risk of having instability and buffering sort of is not enough. Is too much is too much of a risk to take to implement low latency. But again, the DASH-IF and DVB, we are working to sort of take a bit away from these fears of low latency. But these are definitely valid concerns. So you do, the trade-off is basically, yeah, you do trade off some stability for low latency, and also some new technologies, which always brings some uncertainty and problems. So.
Okay, but both the DASH Industry Forum and DVB are working on the implementations there and
yes,
to allay some of those fears.
Yeah, and maybe one thing I can add to the discussion is that we as an implementer, and also just as a general sort of, so what DVB also achieved is that in DASH-IF there was a strong push to have these chunked segments. So which basically changes the kind of segment that clients get, and also it changes actually it can change your whole workflow. But there is also in DVB Dash with low latency, there is a method with short segments where you basically everything is the same as for non-low latency. It's just that your segments are shorter, like 1 or 2 seconds. And by doing that, you have much less of these risks. So there are sort of 2 different flavors in both in DVB Dash and Dash IF to support low latency. One is with short segments, and the other one is the chunk-based. So the short segment-based is a bit less challenging in terms from an interop perspective, and you can still achieve good results by optimizing in other parts of the workflow. So one thing that we have seen is, for example, as a sports provider, that they will get their encoders and their service closer to the stadium, for example, instead of going for this challenge. So latency is really something that is all over your workflow. What DVB Dash and Dash IF have defined is just some additional things that you can use to decrease this latency for streaming. But as the technology is relatively new, I must confess that there are still some risks with deploying this technology. But for example, with the short segment approach, you're already much safer.
Okay, good, thank you. Let's move on with the last part of the presentation. We have about 10 minutes till we need to finish today.
Yeah, I've been a bit slow. So this is a bit about the metadata. So metadata can be signaled in the MPD as MPD events. So here you see an example from the specification. So this is how you can signal this metadata in the MPD. But in some cases, you also may want to add this in the service lists or in the content descriptions from DVB-I itself. So things like the parental guidance rating or the title language and so on. But it's also possible to signal it in the MPD using DVB Dash. So then there's another important topic, which is about content insertion and splicing. So if you want to support this feature in your workflow, one thing you can do, so in HLS you can use the date range stack with SCOTI35. So the dash analog for that is the MPD event, which carries SCOTI35. So it's defined in SCOTI 214, which is basically the SCOTI standard for dash, and also it's adopted in the dash IOP. So I just show an example of that. So basically you have your start time in your presentation of your add insertion slot, and then you have your duration of the slot. And then you have this binary SCOTI35 message, which contains some of the additional information. And then basically, as I mentioned in the first slide, later on in the MPD proxy, you can use this information to replace content that's already stored in the CDN. I will come to that later, but it's important to mention that for interoperability, you can use the MPD event for Dash, and you can use the date range for HLS. All right, so now we come to the MPD proxy. So this is sort of a last part when you're doing packaging and encoding. In some cases, you want to have an MPD proxy, which runs much closer to the users. It may run close to the CDN, but the idea is that some changes are manifest-only changes. So they are basically things like adding supplemental descriptors, adding metadata, changing something to the service description element to change your target latency, but also inserting or replacing content that's already in the CDN. These could be things that could be implemented in the MPD proxy, as long as they do not change the media segments, because they are manifest-only changes. So one example could be really on the geo specific changes, like maybe for maybe at the edge you want to have a different you want to remove maybe some adaptation sets and so on for some countries. But again, there are many use cases where you only want to change the manifest, but not the segment content. Then last, I also have some tips for the origin, which is not really the topic of the presentation, but one challenge of the origin is to handle the scale of the requests. Errors are problematic as they're basically cached in the CDN. That's how it works today. So one tip that we can give is to do a sort of a per channel dimensioning. So if you set up like small virtual servers for each channel, then failures will be isolated. But there are many other ways to sort of reduce sort of the impact of these loads. But overall, based on our experiments, what I wanted to say was that for live, CDN offloading is rather effective because users are watching the same content. Much of this handling of the many requests is at the CDN. However, if you have a misconfiguration of your CDN and many requests start hitting your origin, you will have a scaling problem. But this is, of course, a wrong configuration. Then regarding the service list, so they have to reference the MPDs. In case of live, they will probably be running 24/7 or something like that. So one thing I was thinking for the future was like it might be necessary to have some more methods to announce changes in MPDs or in services, but that's for future discussion. All right, so I reached somehow the end. So I just want to briefly summarize the things. So what I tried to present to you was a distributed workflow for encoding and packaging with a reference architecture, which is basically based on what's discussed in the DASH industry forum for low latency, with some standardized interfaces between functional blocks. Then I talked a bit about DVB DASH and commercial encryption and basically exchanging your key parameters using CPICs. And then something about origin distribution and splice information signaling, program information, and so on. This is all standardized formats. And then I also gave some details about using an MPD proxy, which is basically at the end, when your segments are already in the CDN, you could still make some changes to the MPD for specific use cases or specific needs. So that's about it for today. So I don't know if there's time for more questions, maybe 5 minutes.
Thank you very much, Rufael. Thank you for the excellent presentation. I've received a number of messages myself here already congratulating us on this webinar and very high quality. Thank you for that. And also congratulations to Rufael, who has just recently become the chair of the DVB TM stream working group. So we'll have plenty on his plate going forward there. We do have a few questions. I know that there's one from Tommy Flanagan, which has been answered there on the Q&A interface by John Pising, the chair of our technical module, who's also deeply involved in HBB-TV. Tommy, I hope that answers your question, but we can come back to that topic again in our next webinar on DVB-I. A couple of questions for you, Rufael. Is IMSC1 supported as, sorry, that's a subtitling question. I'll come back to that in a moment. Sorry, I know that Paul is answering some of these questions as well. Here we go. About the DRM key rotation, how is it handled by the CDN that only caches the asked segments?
Sorry, can you repeat?
So with the key rotation for DRM, how is that handled the CDN where it's only caching the segments that have been requested? Does that make sense?
Yeah, well, yes, but I don't think it has any effect on the key rotation, because if you have a key rotation, the key rotation basically means the key is changing over time. So the key will change at certain moments in time, and then basically if you request a segment that's not in the CDN, your request will be forwarded through the origin, and your origin will still provide your segment, and the CDN will cache it. It's just that it will be encrypted with a different key. So I don't think it affects
okay.
Okay,
yeah. And there were a couple of questions there regarding subtitling. I know that Paul Higgs has answered one of those, and John Pising indeed has commented on the other. So you can take a look at those answers.
Yeah, I can have a look. I haven't been very detailed on that, so there are many sub-profiling in subtitles. So TTML is so IMSC1 is basically also TTML. So yeah. Anyway, but I leave to John
but
and
we know
Paul
in any case that the TTML universe, which relates to the EBU TTD and to the DVB TTML and so on, means that there is a lot of interoperability across those different TTML related specifications.
Yes.
A question here, not quite sure I understood you correctly regarding server dimensioning. Do you mean that there is an observable change in the quality of the entire streaming chain if a channel per server was implemented, whether physical server or virtual server?
Yeah, so this suggestion, this is what some telcos or broadcasters, they do it this way. So this would be a virtual server, like so what so can you repeat again the question, because I didn't fully understand the question.
I'll read this out to you. It's in the Q&A interface. Not quite sure I understood you right regarding server dimensioning. Do you mean that there is an observable change in the quality of the entire streaming chain if a channel per server was implemented, whether physical server or virtual server?
Yeah. It depends. Of course, it depends on the overall workflow. But the idea behind this, by running channels separately, is that if there is a failure on the server side, that only one channel is affected. So it's basically about isolating channels from each other. And that's basically an architectural sort of paradigm, basically a microservice-based approach, where you basically run things as small sort of blocks and then monitor those. But yeah, it does change a bit your architecture. So basically some people, they use Docker container to achieve these small server instances. But yeah, there are different ways to do it depending on your requirements. I think when you are designing a full streaming headend, that this is one of the things where you have to be very careful about what would happen in case of like DDoS or failures and so on. So it does change a bit the architecture, but the interfaces are the same, right? So you still have the same interfaces, and for example, if you have an encoder producing one channel, then they can ingest that channel to one packager and so on. So you can have a distributed workflow, and this is one of the things I wanted to show. And we think that this is a sort of an industry trend as well, and it's something that you should consider when you are deploying large-scale encoding and packaging. So,
okay, great. Thank you for that, Rufael. Yeah. We've cleared through all the questions. Tommy's question there is asking about HBB TV and DVB-I. John Peising, who, as I say, is the chair of our technical module, has typed that DVB-I service discovery is a replacement for DVB-SI. So it's a completely different layer in the system from HBB TV. HBB TV builds on DVB DASH just as DVB-I does. The linked application feature, in fact, in DVB-I would likely use the HBB TV browser on the TV screen. So with all of that said, I'm going to say thank you to Paul Higgs and especially to Rufael Mekuria for today's webinar. Thank you to everybody who joined us. We had more than 120 participants on the stream here today. The video will be available to you shortly, later on today. The slides will be available in about 3 minutes as soon as I close this webinar. So thank you very much, and I hope that more of you will be able to join us for next week's webinars. Thank you.